This is 2014 Junior Cert question 8. Table shows in height the meters of a ball at various times after being kicked into the air. This is the pattern of heights in the table. Is it linear, quadratic or exponential? Explain your answer. Okay, so what you're going to do is you're going to look at the gaps between each set of numbers. So you're going to take them away from each other. So what we're going to get is 3.1. We're going to get 2.3 for the second gap. Third gap is going to be 1.5. Okay, so third gap is going to be 1.5. Fourth gap is going to be 0.7. Then the gap after that is going to be 0.1. And then the gap after that is 6.9, so that's going to be it's actually going backwards by 7.8 minus 6.9, and what we get here is so that last one was minus 0.1 and this one is minus 0.9. So what we can see when we look at the second difference is that the gap between all of these is going to be 0.8. Difference between 2.3 and 1.5 is 0.8. Difference between 1.5 and 0.7 is 0.8. Difference between 0.7 and minus 0.1 is also 0.8. So we can see that the second difference is the same. This means that this expression is quadratic. Now, it says estimate the height of the ball after 3.5 seconds. Well, what's going to happen is after 3.5 seconds, we're going to have to do the quadratic sequence. So what we're going to do is, it says the first one's an estimate of 3.5 seconds. So what we're going to do here is we're going to use half the difference. Okay, so you can see that the difference between 6.9, the difference between 7.8 and 6.9 was minus 0.9. So the last difference was minus 0.9. So the next difference should be another 0.8 down. So the next difference should be minus 1.7, and minus 1.7 brings it to 5.2. Okay, and then what we're going to do is that's for 4 seconds. So this is 3 seconds to 4 seconds. So what we'll do is we'll get the average for 3.5. So we get 5.2 plus 6.9 all divided by 2. See this in the calculator. So 5.2 plus 6.9 divided by 2. And what we're going to get is 6.05 as our estimate. Now it says estimate the total time spent in the air, justify your answer. So after 3 seconds you were 6.9 meters into the air, 4 seconds you were 5.2, and as we're saying is that it's going down, that's minus 1.7, and the second difference is 0.8. Okay, so take away 0.8. So the next difference should be minus 2.5. If you're adding 0.8 onto the 1.7, minus 2.5, and that brings us to the fifth second, will be 2.7 meters in the air. Okay, 6 seconds, you add another 0.8 onto this, and you'd be minus roughly 3.3. And minus 3.3 will mean that we're minus 0.6 meters in. So an estimate of this would be it occurs somewhere between 5 to 6 meters. Okay, so what we can say is that the 3.3 here is how much we dropped in total in this second, and to go from 2.7 to 0 would have been 2.7 divided by 3.3, and we're going to multiply that by 1 second. So we're going to say 2.7 multiplied by 3.3. Divided by 3.3 which is 0.82 of a second. Okay, so what we're going to continue our answer is that it was 5.82 seconds, that much in between 5 and 6 as an estimate. Okay, 8 par 1. On the grid below shows the graph to show how much sterling will cost Jack Sarah for up to €80. Sorry. Okay, so we have question 9 here. Jack and Sarah are going to school tour in England. They investigate how much difference the amount of sterling will cost them in euro. They each go to a different bank. The results are shown on the table below. On the grid, draw graphs to show how much sterling will cost Jack and Sarah for up to €80. Okay, so we're going to draw this information in the top right hand corner onto the onto the graph. So what we're going to have here is we're going to start off with Jack. So the first one is 20. €20 goes to 33 for Jack. €40 goes to 56. €60 goes to 79, which is here. And finally €80 goes to 102, which is just up here. Then you can draw your line, which represents, it's linear as we can see, all those points there. Alright, next one is Sarah's one, which is in red. She got 20 for 24, so it's be 24s here. Then she got €48 for 40 sterling. So 40 sterling is €48, which is around here. And then we got €72 for 60 sterling. So 60 sterling up here, 72 here. And then finally €96 for 80 sterling, which is around here. Then we just draw a line to represent all these points, and that's your line there. Okay. Now, that is question 1 answered. Now, using the tables, using the table or your graph, find the slope, the rate of change of Jack's graph, and explain what the value means. Refer to both euro and sterling in your explanations. Okay, so what we're going to do here is we're going to get the slope of the last one. So Jack's one being the blue dots. So we're going to use these 2 points here for Jack. We're going to use the point 2033, which is in blue. We'll use the first and last point, and then 102 and 80, 102. Use the equation of a slope formula, y2 minus y1 over x2 minus x1. And what we're going to get is 102 minus 33, because this is x2, y2. This one's x1, y1. And that's all going to be divided by 80 minus 20. So 102 minus 33, divide that by 60, and what we get is 1.15. Slope equals 1.15. Now, when looking at your graph, please remember that you get more euro for sterling. So sterling gives you this much euro. Okay, so we multiply 20 by 1.15. Let me see. One more second with that. So 102, take away 33, it's the y2 minus 1, and then divide that by 60, because that's 80 minus 20. And what you get is 1.15. Okay, now we're going to try to divide 33 by 1.15. I get 28. So what this slope means is that for every euro you put in, so what it means is for every 1 euro, or sorry, for every 1 sterling, you'll get 1.15 euro. Write down a form to represent what Jack must pay in euro for any given amount of sterling. Clearly state them in the letters. So we're going to use here is the equation y equals mx plus c for the blue dots here. So y equals mx plus c. We drew the line back into the x-axis, so this means that y equals m is the slope, so it's 1.15x. So y equals 1.15 times the x value, which is sterling, and then plus the c intercept, which we're going to estimate at about 11. We'll just rub this out for a second. So about 11. So this will give us an equation of how much money sterling gives us here. So it'll be y equals 1.15x plus 11, where y is the amount in euro, x is the sterling, and 11 is probably a fixed charge which the bank applies to us. So if you test out a point here, so if you look back at the data, we had a 180 sterling got us 102 euro. So if you look at 80 sterling, so replace, so 102 euro will probably roughly equal 1.15 multiplied by 80 plus 11. So we'll check that out. So 1.15 multiplied by 80 is 92. 92 plus 11 gets us 103. So we show that this formula roughly works. Okay. Write down the form to represent what Sarah must pay in euro for any given amount of sterling. State clear what the meaning of any letters you use in the formula. So we're going to estimate the equation of the line for Sarah's one. So for Sarah's one, we're going to get the slope, and then we're going to use the formula y equals mx plus c. So we have for Sarah is 96 minus 24, because the 2 points we know are 80, 96, which is the last point, and the first point, which is 20, 24. So what we're going to get here, divided by 80 minus 20, it's going to be 96 minus 24. 96 minus 24 is 72. 72 divided by 60 is 6 over 5, or 1.2. Okay, so this is 1.2. So we're now going to use the form equation y equals mx plus c, and what we can see from Sarah's formula is that this intercepts at the point 1, so the c value is 1 and the m value is 1.2. So we're going to get is y equals mx plus c, y equals 1.2x plus 1. So we can try checking that formula out for Sarah's one. Y equals 1.2x plus 1, and if you look back at the last question, you can see that an answer for Sarah's one was 96 for 80, so 96 euro for 80 sterling. So what we can do is we can try this out on the calculator, where y is the amount in euro, x is the amount in sterling, and 1 is not so much the fixed charge but the fixed amount you get. So what we're going to get this time around is we're going to see if €96 equals 1.2 multiplied by 80 plus 1. So 1.2 multiplied by 80 plus 1. So it's going to be 97. 96 roughly equals €97, so we can use this formula here. Using the formulas from 3 and 4 otherwise, find the amount of sterling Jack and Sarah could buy that would cost them the same amount each in euro. So what they're wanting us to do here is they want us to find where the two graphs intercept each other. So you can see eventually that down the line the two graphs will intercept, and we want to find out where does this intersection take place. So to find that, what we're going to do is an equation of we're going to do a simultaneous equation with the equation of two lines. So what we have is these two formulas here. We're going to have y equals 1.15x plus 11, and then we have the other one which is y equals 1.2x plus 1. So these two here is what we need to use. So we're going to find out we need to find out the y amount, which is the amount of euro that we get in common. So what we're going to do next is we're going to multiply the bottom equation. We're going to make a simultaneous equation out of this. So we get minus 1.15x plus y equals 11. Then we're going to have minus 1.2x plus y equals 1. Multiply the bottom equation by top equation by minus 1. We get 1.15x minus y equals minus 11. Then we have minus 1.2x plus y equals 1. Then we get minus 0.05x equals minus 10. So what this means is that we're going to divide 10, or minus 10, divided by minus 0.05. We get here is 200. So the x value is 200. Now we have to find the y value. Y value equals 1.15 times the x value, which is 1.15 times 200 plus 11. 1.15 times 200 plus 11 equals 241. So it's €241 for 200 sterling.